Okay, so like I said, let's talk about some of these properties of this function. For example, what is the domain of this function? Negative infinity to to positive infinity, right? All the way to the left, right? We're going to keep going to the left. All the way to the right, we're going to keep going, right? Okay. Is the range also negative infinity to infinity?
Wait, do you want us to draw this?
You don't have to if you want to, but I'm doing it here part of the notes, so I would say it might not be a bad idea. Okay. Is the range also negative infinity to infinity?
No, it's 0.
No, right, it's 0. The lowest point there is 0. Yeah, and then to infinity. Very good. And then include the 0, but exclude the infinity there. Okay? Good. All right. And I won't go, let's see, there's other stuff. Okay. We can talk about all sorts of things here too, like, increasing. All right, where's this function increasing? Is it ever increasing? Yes. At what x value does it start increasing? 0. And then it goes to infinity. Yep. Okay. Is this function ever decreasing?
Would it count for going to infinity to 0?
So is it ever going down from left to right? Let me ask that question.
Yeah.
Yes. It is, okay? So where does it stop decreasing? At what x value does it stop decreasing? 0. Okay, and where did it start decreasing?
At infinity.
So, but coming from the left, so it's going to be negative infinity to 0.
I was just thinking.
Yeah. Remember that for increasing and decreasing, right, we're using x coordinates here. So our graph is coming from the left, right, from the left down. So that's from negative infinity down to, then it decreases down to the little x coordinate of 0 here. And then the x coordinate of 0, the function increases, it's going up, but it's moving to the right, so it keeps increasing to infinity. Okay? So be careful there. We are using x's here for increasing and decreasing, and we use x's for the domain as well. All right, let's see what else. We can do end behavior, for example, right? So as x approaches infinity, f of x approaches. So as we go really far to the right, as we trace along our graph really far to the right, what do the y values approach?
They approach infinity.
Infinity, right? We're going to keep going up and up and up. As x approaches negative infinity, so in other words, as we go really, really far to the left, what do the y values approach? Infinity as well, right? Yeah. Okay. And we're not going to do this for every graph that we do today, right? But I just want to do it for this first one here, so you can kind of see some of the behaviors and refresh our memories a little bit, right? All right, one more here, and then we'll move on. All right. Is this function even, odd, or neither? Okay. It is. It's even. Very good. Okay. Why is it even? What makes it even? Yes, you reflect over the y-axis. You have the exact same graph there. The exact same graph. Okay, bless you. Okay, and so that's exactly right. Okay, and remember it has to reflect over the y-axis and match back up. All right. By the way, this point right down here at the very tip of that graph is called the vertex, right? And we're going to be using that to help us transform our graphs. Okay, we're going to use that to help us transform our graphs. All right. So let's do this here. Let's try another graph here. So let's graph f of x equal to the absolute value of x minus 2. Oops, I got to zoom out a little bit there. Okay. F of x equal to the absolute value of x minus 2. Okay, so we're taking that parent function, the absolute value of x, and I'm putting a minus 2 on the outside. You guys remember when we did transformations in the past, right? What is that minus 2 at the end? What does that minus 2 do?
Down.
Down, how much?
Down 2 units.
Yeah, down 2 units, right? So our vertex here is normally at 0, 0. So I'm going to start at 0, 0, but we're going to count, like John said, count down to this point right here. That's our new vertex. Okay? And at this point then, if you want, you could use a table to get more points, if you really wanted to. Okay? So you could go like to the right of the vertex and put in some points. Go to the left of the vertex, put in some points, right? we can see here that when I shift this thing down, the shape of the graph is still going to stay the same. So from my vertex, if I just go up 1, right 1, I'll get to another point, right? And then go up 1, right 1 again, I get more points. Up 1, right 1, up 1, right 1. So I don't even need to do a table if I don't want to. I just go up 1, right 1, and there's a point. Up 1, right 1, up 1, right 1, up 1, right 1, and then just connect those dots. Diagonally like that. And then, of course, by symmetry, instead of going up 1, right 1, I could go up 1, which other way? Left 1, right, to get more points, yeah. So up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. Okay, and connect those dots. And that's the answer. We took all of these points on the original graph and we shifted them all down 2, right? So these are all just shifted down 2 from the original graph. Easy peasy. Any questions on any of that? All right, let's try another one here. I'll kind of scoop this up some. Let's see, can I fit them? I'm trying to fit them both on here. I guess I'll use this one. And we'll go ahead, we'll combine some transformations now. So let's do f of x equals the absolute value of x minus 3 plus 1, like that. What transformations do we have here? Well, let's see. The minus 2 on the outside, we now have a plus 1 on the outside. So that plus 1, how's that going to transform our graph? Up 1, right? But that minus 3 on the inside with the x, how's that going to go? To the right 3, okay? Remember that number that's in with the x, you do the opposite of what you'd expect. So you see a minus 3, you think, oh, minus 3, go to the left. Nope. We do the opposite, we go to the right. With this plus 1 on the outside, you do what you would expect. So you do up 1. So this is, right 3, and then up 1. Okay, and I'm putting them right by what they, how we know that. So from the origin, because that's where, again, where our vertex starts, from the parent function there, go right 3 and up 1, just like that. Okay, you can put them right there on my keyboard, Rohan. Okay. Our graph's shape does not change, though, right? Because we didn't stretch or shrink it at all. It stays the same. Mm-hmm. So then from this vertex, how should I go to get more points? Left. So I can go which way? Up 1, right 1. Yeah, I get more points. Up 1, right 1. Up 1, right 1. Up 1, right 1. And instead of going up 1, right 1, I can also go up 1, left 1, up 1, left 1, up 1, left 1, so on and so forth. Okay, and then connect those dots. So there it is with 2 transformations, right? We go right 3, we go up 1. Okay. Questions so far? I got 2 more here I want to show you. Okay, f of x equals 2 times parentheses, or absolute value x minus 1. Okay. So what kind of transformations do we see here for this one? So, Mike?
We're not stretching.
So which one?
The one on the outside.
Yeah, the number 2 is going to do a vertical stretch times 2. What's that minus 1 on the inside going to do? Not up 1.
Down.
It's in with the x. So it's going to go which direction?
Right.
Right 1, because it's in with the x. If you had something on the outside, the absolute value over here, then you would have it go up or down. But since it's in with the x, you're going to go right 1. So let's go ahead and go right 1. Okay, so there's my new vertex. I just shifted it right 1. Okay, but now that vertical stretch of 2. So let's think about that. Before, I was going up 1, right 1. But now I need to double that. So instead of going up 1, I need to stretch that vertically times 2. So instead of going up 1, I'm going to go up how much? 2. But I'm still going to go right 1 because I'm not doing a horizontal stretch at all, right? This 2 is just a vertical stretch. So I'm going to go up 2, right 1. Up 2, right 1. Up 2, right 1. Do you guys see that? If I put this 2 as a fraction, 2 over 1, this is the slope, right? That's slope. Rise of 2, run of 1. 2 over 1. So I'm just doing the slope here. Up 2, right 1. Rise 2, run 1. Rise 2, run 1. And then by symmetry, I will also rise 2 and go what other direction? Left 1. Rise 2, left 1. Rise 2, left 1. Okay? And just connect those dots. Like that. That's all there is to it. So this number, if you ever see a number in front of your absolute value, that is just the slope. That's all it is the slope. Okay? It's just the slope of the one side, and then you have to do this, use symmetry to get the other side. All right, so I got one more for us here, and then that's all I think I'm going to give right now. Okay? Yes, we'll have a few problems for homework. But just like these. Okay, one more here. And sorry, I know I'm rushing through this, and I would have given you guys more chance to try some on your own, but I just wanted to make sure we saw all I wanted to see here. So, okay, this is as complicated as I'm going to make these graphs for you guys that you'll have to do. Okay, for me. All right, it's got everything. Negative 1/2 is it's actually a vertical shrink because it's between 0 and 1. What's the negative going to do? Yeah, flip it over the x-axis, right? So it's not going to, the v won't open up, the v will open down. What's the minus 1 going to do here? Right 1. And what's that plus 2 on the outside going to do? Up 2. So, up 2. Right 1, so I'll go ahead and do that right now. Up to right 1, there's my new vertex. Okay, and then this is like the slope if you want to think about it. Okay, and we can really call this the slope because an absolute value is really just 2 lines. Okay, it's 2 lines. The positive version of the slope of that line and the negative version of the slope of that line. Okay. So here we're going to use this slope to get more points, right? Just like you did back when you were graphing linear equations, right? We graphed our vertex here, and this slope is negative 1 over 2, which means which direction will I go here to get more points? The rise is negative 1, so it means I have to go down 1 and then positive 2 for the bottom, so that means I'm going to go which direction? Right 2, yeah. And then down 1, right 2, down 1, right 2. And of course, by symmetry, instead of going down 1, right 2, I can also go down 1, left 2. Down 1, left 2. Okay? Just like that. And there's our graph. Okay, so you can see the flip, right? You can see the vertical compression, right? Because it's a 1/2, so it's compressed vertically. Shifted right 1 and up 2, and that's the graph. That's what it looks like. Okay. If you don't believe me, or if you ever want to check your work, you can always go to your graphing calculator. There will never be a quiz or a test where I don't allow you to use your graphing calculators, and you can literally type in, in parentheses, negative 1/2. Okay. Then to get the absolute value command on your calculator, you have to press the math button, and then arrow over to num, and then you're going to use ABS. Okay, you see the absolute value, so I'm going to show it for me. X minus 1, put the plus 2 on the outside, and graph it. And see, there it is. Okay. All right, yes, we are out of time. So let me give you guys your assignment. Okay, and we'll just say the 6 here that are on the front. Okay, so all of the front of this paper here. Okay, count. Okay, so there's 6 problems on the front, 6 graphs for you to do on the front. Take one, pass it all the way down. Just the front of the paper, please. 1,
5.
5. Pass down, please. Just the front of the table. 6. All the way down. Thank you, Rohan. Compare that. Much appreciated. Yes. Okay. I'll figure that out then. Thank you for trying to figure it out. Yeah, something that came tomorrow. So that's true, Samantha. Otherwise. Oh yeah, let's go do that. Bye guys, have a good day and a good weekend. Let's go, Robbie. We got stuff to do.
Have a nice day.
You sure? I'm gonna put my warm-up on. I'll be right there.
Mr. Wynn, sometimes Luke acts like my father figure.
Is that right? So Luke is your father?
No, for some that first Star Wars. Like,
I know, yes.
But for some reason, he always tells me what to do. Like, okay.
I guess he knows what. If you trust him, then I guess you should follow him. You know?
Yeah. If he says I have to go to LA, I guess I have to go to LA.
Yes.
Can I quickly turn on my schedule change?
Ooh. Wow. Your printer is a real winner there. But yeah, go ahead. Yeah, I hopefully they'll take that.
Yeah.
Yeah. If you want to. Mr. Wynn, do I ever want to take a quiz?
I don't want to take it.
Right. Just rip it off like a Band-Aid. I understand.
Happy birthday, bro.
I understand.
Yeah, I don't do that. Appreciate it. No, I have my way right now the whole time. So you told me what to say. So
Alrighty, everyone. Good morning. Welcome. All right. Hope you enjoyed your little 1 hour delay there. Ish. You know, whatever. So yeah, I got a one for you here. Kind of an interesting question. All right. So I'll read through it here. Try and help you like understand kind of what's going on because sometimes it's hard to translate the words into like a picture and stuff. Right. So we're at a science museum, let's say, and there's a beam of light. Okay, that is originating on a wall 10 feet above the floor. Okay, and that beam of light is kind of like angled downward, okay, and then the light beam is then reflected off a mirror on the floor that is 15 feet from the same wall, okay, and I want to know how high off the floor does the light hit on the opposite wall if that opposite wall is 8.5 feet. Okay? There's many different ways you can do this, okay, or at least I can think of 2 different ways to do it. Maybe I shouldn't say many, but there's at least 2 ways I can think about doing this, so you might be able to figure it out a couple different ways. But see what you come up with there, okay? And, yeah. Okay. Try this off the way correctly. All right, and I believe we had homework. So I'll come around and check that.